It's live. I'm 30 seconds early. I'll let you guys settle down. While we're getting started, how many people have actually done any games programming? Oh, God, I'm in trouble. How many people want to do games programming? Is that less? How many people have used Unity? All right, that's pretty good. Hopefully I won't embarrass myself too much today. I would like to start off and say that you guys frankly intimidate me. My background is not in coding. My background is in visual effects for film and television. Who am I? I'm Adam Buckner. I'm a trainer for Unity Technologies. I did some games development on my own for a while and then was headhunted by Unity to come and do their live teaching. So I teach an hour every day, usually right now on a Mondays. So if you want to come by, we do broadcast on Twitch. But my background is not in coding, it's not in programming, it's in visual effects for film and television. And when my son was born back in 2008, actually, I was looking at Unity as a render engine back in 2007. I had to teach myself coding from nothing. So I look at the people like you who actually know what they're doing, and I'm in awe. I'd like to get a blood sample or something and actually sort of pick it up, rather than doing it the hard way like I am. But at the same time, since I didn't have any coding experience, I think it goes to show what you can do with Unity, that you can pick it up, that you can find, that you can use it relatively easily, and especially with your background in C#, you should be able to do some wonderful things with Unity. What are we going to do here today? Well, we're going to learn how to make games in Unity. What I want to do is sort of interest you in the Unity, see if you'll follow it up, keep playing with it. By the end of the session, I'd like to say that we know more about Unity and Unity Technologies as a company. I want to talk about the basics of the editor environment so you can get an idea of how to work inside the editor. And I want to talk about Unity's game object component pattern. It's a little bit different. We're not running anything in Unity. You're not running a main thread. You're pushing Unity around. You're writing behaviors rather than punching pixels and really moving vertices down on the basic level. And I'd like to talk about how to approach coding for Unity in C#. And then if we have time, I'd like to make a simple game-like example. We can't really, don't have the time today to really work at making a game. We only have an hour, and a lot of my classes start off at an hour, and often some of the big ones can last days. We can do seminars that'll last a week of full days to teach people how to use Unity. And then at the end, I want to give you guys some resources on how to keep going. And then hopefully we'll have some time for Q&A. If we don't have time for Q&A here, find me. I'll be around. I'll hang out. I definitely want to go to the drinks that was announced at the end. I'll be around, and I'm accessible, so come up and talk to me, and I'll try to answer any questions that you have. And maybe some preview features of Unity 5. Some really nice stuff looking at Unity 5. We're on the cusp. Unity 5 is in late closed beta, so we should see that. We also have an open beta of our 4.6 software available right now, which is mainly featuring our new UI tools. So where did Unity come from as a company? Unity Technologies was founded in 2004 by David Helgeson, Nicholas Francis, and Joachim Ante in Copenhagen, Denmark. So they're just across the water for you guys. And their mandate was to democratize game development and make it easy for people to use. And now Unity Technologies employs over 400 people all around the world. And it's been quite successful. It's a global, diverse, and eclectic company. We have 18 major offices all around the world, plus people like me who get to work from home. So big game developers, they're happy, they're productive. We have a 45% market share of people using middleware for game development. We have 47% of the developers use Unity at some point. Most of them as their primary tool. We've got 3.3 million registered developers, and we have 600 million people using our games. We're cross-platform. We can deploy to iOS, OS X, Windows, phones, desktop, Surface. We can deploy to Linux, Android, BlackBerry, So many of them. PlayStation, Xbox families, Wii, and the web, and we're unrolling WebGL, which will be coming out, so we won't need a plugin. And there are more platforms that are usually slightly more closed. There are smart TVs and other places that you can get your games on. And we make games, lots of games. Lots and lots of games, including some non-game stuff. If you look at the left-hand side, that's a virtual showroom, some medical diagnostic software. Actually, lower in the middle, and tattoo software as well. But lots of games. So, and lots of different styles of games as well, as you can see. And some that you may recognize and some that you may not. So what types of games can we make in Unity? Well, as I said in the description, 2D, 3D, isometric, top-down, first-person, turn-based, real-time stealth strategy, action, casual, tile-based, procedural sandbox shooter with racing and puzzle, etc. Essentially, if you can imagine it, you should be able to build it. I have not yet seen anyone who has imagined a game that they want to make and haven't been able to make it in Unity. One of the things that I really like about Unity is that it is really not just platform independent, it's game style independent. It isn't based on core code for any particular style of game. You're not taking, say, a first-person shooter or a third-person RTS game engine and repurposing it for another type of game. You have a base, empty, clean framework that you can make any type of game you want to in. So let's quickly jump in and take a look at the Unity editor. So this is the Unity editor. And what we're looking at is Nightmares, which is a little survival shooter. Come on, let's bring that up. Unity, please. Oh, and we didn't hook up audio, did we? So, didn't think of doing that, but let's see if I can turn that up. How's that? But anyway, so we've got our little character here, and so we've got that's the editor. We can go ahead and play our game in the editor. I want to go over a brief description of the views, the windows that we work in the editor in. There are a number of windows or views that we use to create our games. We have the project view up here. The project view is, sorry, the scene view here is where we manipulate all of the items in our game. We have the game view at the bottom, which is where we play and test our game. We have the project view. The project view over here is where we store and import all of our assets. And I'll talk about that a little bit more in just a second. And I'll go into each one of these windows in a little bit more detail. We have the hierarchy view. And the hierarchy view lists all of the game objects, all of the instances of objects in our game, in our hierarchy, and they are listed in a hierarchical order so we can see the association of all of the objects in our game. We have the inspector view, and the inspector view allows us to look at the details of any particular game object and all of the components that are on that game object. And I want to talk about the game object component pattern a little bit later. We also have the console view, which is very important. If it's not docked, we can get it from Window Console. And this is where errors and messages are displayed. And you can also put debug code that you want to display in your console here. And you can find that in the Windows menu. And if you want to, you can dock it. The whole editor is dockable. It's rearrangeable. You can save your layouts. And just as an aside, the whole editor is actually written in Unity's, it's basically written in Unity in its own editor language, so that you can completely rewrite and redesign the look of the editor if you need to, or if you want to. You can write your own editor tools. You can rewrite the way that the windows work. You can add menus and add tools and menus to the top of the menu bar. So it's fully customizable. And like I said, you can rearrange, you can redock, and we can save our layouts. So if you want to return, you can simply pick that layout again. So when we're looking at specifically at the different windows, if you want to look at the project window is where we import and store all of our project's assets. Now, assets can be models, textures, they can be sounds, or they can be anything that you are importing. I'm going to just look at this in my Finder. And if we go ahead and take a look at this on the desktop level, we can see that these are simply the original files here on on our desktop, and we don't modify any of these files when they come in. During our import process, if anything is adjusted, the asset's duplicated, it's brought into the library. But because of this, there's a little bit of a gotcha that I want you to know about, because sometimes when people just get started, they can make some terrible things for their game if they get in and fuss with this. Because of the way that Unity is working, it's looking at your project folder, and looking at those assets, and it contains metadata, and it wants to keep track of where all of those assets are. So you can add new assets to your project folder, and they will be instantly imported. But you shouldn't rearrange, rename, or reorder anything on the operating system level once you've put it in. If you want to delete, change, reorganize, or reorder, do that inside Unity, because in Unity, it'll keep track of it. It'll be able to use the GUI IDs and be able to keep track of it. Unity's smart enough that if you did delete something from the operating system level, it can figure it out. But it's probably not that smart to tempt fate. So do all of your management of your project once you've imported things. Do that inside the project window. And I will talk later on about how this is an advantage when you're using external version control. The hierarchy view up here, this works very closely with our scene view, the scene view here, because they both look at all of the objects in our game. So if we look at these objects, they are instances of assets. So we can see that we have got a camera asset. Let me just move this over so we can see that the game object that's there. If we want to look at our player, so the instances of our objects are listed in the hierarchy view and are shown in the scene view. And we can also create new objects if there are certain primitive objects and styles of objects that we want that aren't necessarily something that we import, that we can bring them in from the create menu. Like we could bring in an additional light, kind of ugly, but you know, primitives, that sort of thing, you can bring in directly into the game object from the create menu. Now, before I go into scenes, I sort of want to talk about what scenes are. Many people think of scenes as a discrete level, like a level of your game. Well, scenes can be a single level, but also you should really think of the scene as the area that you are, just as a work area, an area that you're working in, because you can have multiple scenes per level if you wanted to. If you imagine that this was a little puzzle game, and that the person figures their way out through the maze, and then you want to go ahead and go on to another level, you don't need to load a new scene. You can simply have that you can have that a second level in the same scene. There are some games like, I think Cut the Rope works this way, where you have a box of puzzles, which they've got 20 puzzles in. And each one, you go through and it loads relatively quickly right into the next game, because it's all in the same scene file. It's in the same environment. And you simply turn on and off the game objects that you need until you reach the end of that box. And then when you want to continue on to the next box, you dump all of the instances that you have, and then you load up a new scene, which has another 20 puzzles in it. Also, you could be using loading on the fly. You could bring in things into the scene. You can dump things out of the scene. Think of a large MMO-style game, where if you wanted to bring in new territory, you've gotten too far away from stuff, you want to dump them out, you're all going to be running in the same scene. So don't get too tied up in scenes as being a level, but the scene is the workspace that you're instantiating your current set of objects with, and you can bring some things in, and you can dump them out, and you can have multiple game levels in the same scene. Now, the scene view, as we see it, we can use it as an overview of all of the game objects. We can move through it by, you can double-click on an object, and it will focus on that object. We can also zoom and pan and move around, and this is also where we can manipulate and move our objects in 3D space. So we can move them, we can rotate them, and we can also scale them. So this is where we're moving our objects in 3D space. We also have a 2D mode for doing 2D games. So everything is flattened, is orthographic. We're not going to go too much into 2D games, but we do have a 2D mode and a 3D mode for our scene view and for the game objects that we're using. You can search. Oops, come back here. You can search your hierarchy if you're looking for things. So if you want your player, you can get, and you can see that we're all grayed out except for the objects that we want, so that it helps us focus what we're looking for. So you can search through your hierarchy. You can also search through your project. When we're looking at, let me go ahead and clear that. When we're looking at the inspector view shows us the game object that we have selected, which is the title on the hierarchy, and also shows us all of the components on that game object in the inspector. So the way that Unity works is with this game object component pattern. So we have game objects. They are essentially empty holders. They're empty containers for components, and the components give behavior to our game objects. There are a number of built-in components that come with Unity that are from the 2D physics system, from the 3D physics system. They're from our animation system. There are state machine. And then there are also the scripts that you write yourself. This player health script is a component that has been written in C#. And this is what we're, as game developers, what we write to push around the game that we've made. And so when we're inspecting that game object, we can see that we have, in this case, we have the hearse, which is this little mesh here. And we've got the game object's header, which all game objects have. And all game objects must have a transform of some sort. So all game objects have basic information that basically it exists, it's turned on, what its tag is, and where it is in the scene. It's got a position, a rotation, and a scale. So if you've got a center point, a position, rotation, and scale, you can define any object in 2D or 3D space. And then we have components for the mesh filter that hold the mesh. And then we have another component that is used to help render that mesh. And then we have a box collider around the outside, and that defines the collision volume that's going to be used by the 3D system. So we've built up this object from a base game object and a series of components that we've added onto it. And of course, what we've seen down here is the game view, and that's where we can play our game. And currently I have it set to stays in the screen size. You can also set it to maximize on play, so it will fill up the screen when you play. And this is where we can play our game, we can pause, we can step through the game one frame at a time. And then, as I said, we have our console view down here. And when we've got errors and messages, we'll see that in the footer. So even if we're in a different view or if we're in full screen mode, if we get an error, if we get a message, we will see it in our footer. And if we double click on the footer, we'll get the console. It'll pop up even if it's not docked. So no matter what view you're in. Oh, we've been retweeted. I forgot to turn that off. Somebody loves us. So that's the basics of the editor itself. And as I said, that Unity works using game objects and their attached components, and our gameplay is made from all of these components interacting and reacting with each other. And we create our own behaviors on our game objects by writing logic, and we write that logic in our C# scripts. So let's create a new script. I'm just going to make a little quick sample script here. So I can just create a new C# script. And so let's just call this example script. And then I'm going to go ahead and run that. And by double-clicking it, it's just running it in monodevelop. Now, monodevelop is the IDE that's bundled with Unity. And it's designed to work with it. You can debug inside Unity. Yes? Ah, yes. It's always funny in monodevelop, actually. There we go. How's that? But you can use any IDE that you want. You can use Sublime Text. You can use Visual Studio. For simply writing the scripts, you can use any. You could use text editor. You could use Notepad. But if you want to be able to debug, right now you need to use monodevelop. or Visual Studio. There was a plugin that was written to Visual Studio by a third party, and Microsoft has just recently purchased it. I don't know the state of that plugin, but it's Visual Studio for Unity. So you can use, especially if you're on Windows, you can use Visual Studio. You can take a look at their plugin, and with both MonoDevelop and with the Visual Studio plugin, you should be able to do proper debugging, where you step over and step out and put in your breakpoints, and you can debug your code properly through one of those two packages. Now, scripts must be attached to a game object to have any value. You can write some non-attached classes if you call them from a script that's attached to a game object inside Unity. But to be called, to be used, you need to be attached to a game object. And to be attachable, your scripts need to derive from something called monobehavior. And you can, and in some cases I've known some people to do this, where they derive from monobehavior, and then they derive all of their scripts from that for organizational purposes. But ultimately, you need to derive from monobehavior to be able to attach your script to your game object, and that'll allow your game object to be called. The other sort of gotcha is that your file name, which needs to end in .cs, needs to also match the main class within the script that derives from monobehavior. So if you notice that our example script CS and example script is our public class. And just as when we attach that script to a game object in Unity, it creates a new instance of the object that's described inside the script. So if you want multiple instances, you attach those to multiple game objects. And in some cases, you can attach them multiply to the same game object. Now, Unity supports inheritance and polymorphism, but in general, Unity works best with a componentized architecture, as we've seen. And so our scripts should have single responsibility. They need, like an input, like if you want to do input components, you could have one input component that takes player input, another input component that takes input from your AI. Maybe it works with the nav mesh. And then you have another component that's a motor that moves your objects around. And it can work with the AI and moves all your AI creatures around. And it works with the player input, moves your player around. So what generally works best is to come up with small scripts with single responsibility that are modular and componentized. And they're also reusable. Now, within reason, these scripts start to access each other. And because the scripts need to know where other scripts are, what other components are. And this is where you can start to use forms of abstraction and inheritance and dependency injection and interfaces and to reduce the actual dependency between the components. Because in one sense, you do get the advantage with componentized architecture of reusable and modular behaviors on your game objects. But if you're not careful with the way that you write some of these, they can start to become heavily dependent on each other, which can cause some problems. So just be aware of how you deal with your dependencies. Now, some coding things of note. You can use .NET. And so if there's something that's not in our API, a lot of newer users, probably not from your group, is you know what you're doing, will assume that if it's not in the API, that you can't do it. But you can, if you want to MSDN, you can look at anything in .NET, you can write that into a script, it'll work just fine. You can use link. But there has been some debate about the allocations and garbage collection around using link. So some people love link. It makes such neat little lines of code. Other people, of course, find it harder to read and worry about the allocations that are being made by link. Unity supports generics. And you can also use C++. I don't know if that's a bad thing to say here. But if you want to, you can use, if you've got C++ libraries, you can use that. And using it as a plugin, you do need Pro. Under the current licensing scheme, I can't talk about what's happening in 5, but in 4.x, you need to have Pro to be able to use plugins, but then you can use your C++ libraries through plugin into Unity. A couple other gotchas. No constructors. You won't be using a constructor when you make your class. Construction is handled by the Unity editor. And construction doesn't happen when you start the game. Construction is handled by Unity. And And if you define a constructor in your class, you could start to interfere with the normal operations, the way that Unity works. Now, there are other ways that we can initialize our values. If we were to create some, I don't know, some simple variables, we can say an int my int, and maybe a float. How about that? My float. We can initialize these in the editor. So if I've made these two variables, and then we can come to Unity, and we will see them when we attach this to something. Let me just attach it to our player down there. Player. Oop, just close that down. Come back to our player. And we can now see, so get it all visible at the bottom. There we go. Oop, what have I done wrong? Example script. Example script. Oh, public. I'm doing just great here now. You see, I know how to code. Trust me. I'll fly your airplanes, too. That's probably a throwback to my original learnings of stuff in JavaScript. There we go. Public. A couple of things that I think it's called, am I correct? Is this called Pascal case? The type of camel case that we're using. But, and if you notice that if we, I'm just saving that, get rid of that extra space, that we've now made it more readable, so when that script is compiled inside Unity, it no longer has Pascal case, it's capitalized. So we can initialize these by just typing in values in the inspector. The other thing you can do is you can initialize them in the start function, or in awake. I'll talk about functions that are called regularly. The other thing you can do is you can also initialize these when you declare them. I mean, some of this may be obvious to you guys as well. But one of the things that I think is interesting to note, I've now declared these with a value different from the ones I've made in the inspector. If I come back to the inspector, oh, I need my F. There we go. What have I done wrong? Oh, I missed the F. Put it down the wrong line because I'm not paying attention. And it's a D. Crackers. Who hired this guy? There we go. Notice that my values haven't changed. The inspector is going to override the values that you put in when you're initializing the values in your script. Now, if you wanted to reset the component, it'll go back to those values that we've set. But the inspector is going to override the values you put in the script. So even if you initialize those values on declaration and you change it in the inspector, you're going to override it. Unless, of course, you do it in start, and start will then, because that's when you're running the game, is going to override the inspector. We don't run anything when we're in Unity. Unity runs itself. It's got its own game loop. And it's a continuous loop. It's one loop per frame. And there are many regular functions that Unity is going to call. It's going to call things like awake or update that you see here, including other ones called fixed update and late update. Let me quickly show you something that just for you to remember, because you will be able to find this on your own. I'm going to go to the Unity manual. And I'm going to look up event. And if we look up execution order of event functions, they describe them, and then also we show you the order of all of the, see if I can bring that up. That's just mostly for you to remember that you can look this up in our, it's very small on the screen, so you can look it up in our documentation. So you can get all of the functions that are called by Unity, so you can figure out what order they're called, so when you're describing your behaviors, that you will know how to write your code. MonoDevelop is bundled with Unity. We talked about this earlier, and you can attach Unity. You can set breakpoints. You can step through, step over all of the things that you expect to do in debugging. And as I said, Visual Studio has a plugin, and you have to take a look at Microsoft and find out what they're doing with that. We also have a debug class, which can be helpful when you're making your game. Come back here, Chrome. Let me quickly bring up the documentation again, because I want to quickly show you that. Debug. Debug class. And you can set breaks which pause the editor, but some of the other things that are important, especially when you get into playing your game, where you want to know where things are looking, you want to know what the way a spaceship is flying, what a gun is shooting at. There's debug draw line, debug draw ray. So there are different things that you can do inside your game to help you debug your game while it's running. So you can draw lines, you can put in icons, you can do gizmos inside your game that will help you debug your game while you're running it. Also, for debugging, we have the profiler, which is currently pro only. And good gracious me, where is it? Profiler, there we go. And so the profiler goes ahead and shows what's going on when you're running your game. So if you run your game, you can see every process that's going on, and you can see where your performance is going. So you can see if there's problems, if there's issues. You can break down. Oh, I'm dying in the background. So you can take a look at all of the different things that are being called. You can see how what the garbage collection is, what the draw calls are. You can take a look at how much of your processing time you're using up. So you can use that to help debug your game and help optimize your game as well. Source control, version control. Pretty much any exterior version control will work. Currently, I'm using Bitbucket, Mercurial, and SourceTree because that's what our Learn department uses. But you can use GitHub, you can use whatever form that you want. And the nice thing about the way that those work compared to the way that Unity imports things is you can save, you can push to your changes to your source control, and then when you want to do a pull, you can simply pull it. It'll overwrite the files in your project window. Unity will see the changes to your project and re-import all of the assets that need to be re-imported. And so essentially, I find that when I'm doing it, it's seamless behind the scenes. When I'm done working a session, I can push what I need to push. If someone else has worked on it or I've worked on it on another machine, I can just bring it down. It'll overwrite my project, it'll update my project. Unity will look at the files that have been updated, and it will bring those in and update my project with all the changes that have been done. Cool. We might have enough time. So I want to do a real quick, see if I can get it to work in Unity and show you how quickly it is that we can get a game object into the scene, write a simple script for it, and have it start working in our scene. And so what I want to do is I want to take a spaceship, I want to slap it in, and with asteroid-style movement, get it moving. So I'm going to create a new scene. I don't want to save that. Bring back my game. I'm going to go into Space Shooter, and both Nightmares and Space Shooter are available on something called the Asset Store, and I'll talk about that in a moment. Find my model, and find my player ship, and just drag that in. So there's my player ship. I'm going to just rename this player ship. Looks a little less cryptic than vehicle player ship. And so there's my player ship in the scene. There we go. And then I'm going to take my camera, which is looking behind it. I'm going to put it on top. So let's go ahead. I'm going to reset that back to origin. So they're now sharing the same space. I'm going to rotate that camera 90 degrees down and then just lift it up so that I can look down on my game board. I think I'm just going to put it out to an even, to sort of 10 units. And the next thing I want to do is I'm using a perspective camera. You can see the perspective frustum that's going on. I'm going to turn this into an orthographic camera. And you can see that we've lost perspective because that is coming straight down as a box down on the game. I think my ship's a little bit big, so I want to change my size, just make it a little bit smaller. And now, and let's give us a black background because it's space. We need a light to be able to make that look any good. So let's create a new game object. This is an internal one. This is not an asset that I've imported. And then we want to bring in a directional light. And I'm going to adjust the lighting on that just a little bit. Let me just bring that up so you can see what I'm doing. I'm going to change its rotation on the x-axis to about 20, because I like it when it rakes along the side, gives us some shadows. Make it look a little cool. And let's save this. I'm going to save the scene as demo. I already have one there. We'll replace it. And now I've got my basic art set up. I brought in a model. I've added a light. I've adjusted that light. I've moved my camera. So I want to write a simple script. So let's add a component. Let's add a new script. Let's call this player controller. And so we can see that it's automatically attached the player controller because I've attached it. It's created that player controller script. And I can go ahead and, let's not say that. And there's my player controller script. And again, we've got that base code that gives us the start function and the update function. So I want to define two variables. And these are going to be my move speed and my turn speed. So, and now I want this to be something I do in the inspector. So I am going to remember to make it public. So it doesn't help when it's private. So let's make a public float, and let's call this one move speed. And let's make a public, thank you, public float called turn speed, surprisingly enough. And then I also want to be able to address some components that we're going to put on this game object. I want to address the player's ship's transform. I'm going to just put that exactly back at 0. So reset that to 0. And then I also want to address a physics component called rigid body. And this allows physics to work on this particular game object. So now my player's ship has a rigid body, and that rigid body gives me mass, gives me drag. It all hooks into the 3D physics system. And because we're making sort of an asteroid-style game, I want to freeze the position on the Y. I'm not going to give this any forces that could push it off the Y, but I want to hold it there on that Y plane, so I don't want it to go away from camera. And then also, I want to freeze the rotation on the X and Z, so I don't want it to pitch or roll, just yaw. And then when we come back, I want to address these two components, and they're going to be private. Rigid body. Not 2D, just the rigid body, please. And I'm just going to call this one my rigid body. And then another private, the transform. And I'll just call this my transform. Now, currently in 4, you don't need to do this. In 5, which is coming up, you will. Because to make things a little less dependent inside the engine and to also allow more versatility of like dot release updates, we're removing a lot of our helper functions that were nice to use, that you could just simply address a rigid body with a keyword and you'd get it, but also slows down the games a little bit and also makes the engine a little bit more unnecessarily complicated. So I'm going to make this future-proof for 5. And in start, which is the beginning of when the scene loads and this game object becomes enabled, I want to find those two things, the rigid body and the transform. So I'm going to do a get component. So I'm going to get the component, and this is a generic for the rigid body. And then I want to say my transform is another get component. So I'm getting the components, and this works for finding the component on the same game object as the script. So I've set up the variables for it, I'm finding the reference, I then go ahead and get that component. And then in update, this is called once per frame. Every time it goes through the game loop, it's going to call update. And what I want to do is get input from the keyboard. I'm going to call it move horizontal. And that's going to be equal to the input, and we can look up input some other time actually, we get an axis, and this is going to be the A and D keys, or the joystick will be also, it could be from a joystick or from any of the input devices. It's going to be our horizontal axis. And then we also want to grab our move vertical, which is going to be equal to our input get axis. Vertical. And then we simply want to add torque and add force to the rigid body. So we say we want my rigid body, add torque. And the torque that we're going to add is going to be the transform we found, my transform, up. So that's going to be the y. So we're going to be looking for torque around the y-axis times, times please, our turn speed. Well, let's say move. I'll probably more organized to say move horizontal first. Move horizontal times our turn speed. And then our, we want to take my rigid body again, and we want to add force, and we want my transform forward. And that's along the z-axis times our move vertical times our move speed. I've done something wrong, I think, because I'm not getting code completion. Let's see. Save that and ask for the compiler to tell me what I've done wrong. Ooh, seems to have worked. So now, save, play, and we're not going to go anywhere because we need to set the values in that script. So our player controller. So I think I'm going to try about 50 and 100. I think 5 and 10 because we're using update. And I want to talk about update and fixed update in a second. So yeah, 50 and 100, if I remember correctly. Now, whoa, and we're gone. One of the things I've done wrong here is I've used update. And update is called once per frame. And when we're dealing with our physics, we have a special function that we need to call, and it's called fixed update. And there are a couple of these, and you'll find that when you look in the API, when you look at that event, order of events. Fixed update is not called once per loop, not called once per frame. It's called on a fixed time scale. And the reason that we want fixed update for our physics as opposed to update for our regular game, which is that you process all of the behaviors, you process all of the changes, you figure out and you apply that to all of the game objects, and then you render your frame. But if you have physics involved, what you don't want is in a very simple scene. Imagine a big space battle. Well, we're going to make Elite dangerous today. And you're by yourself, and the only thing that you can see is a spaceship, your spaceship, and a planet, and maybe the procedural stars in the background. And you're going to get a really high frame rate because you can process this stuff very, very quickly. And if you do your physics, you're spending a lot of wasted time calculating your physics all the time. But then you get into a space battle in the asteroid field where you've got asteroids as far as you can see and lots of explosions and tons of stuff going on. You don't want your physics to start malfunctioning because you don't have, you haven't done calculations enough, and things start passing through each other. So we have fixed update, which is actually called on a regular beat. And you can set that currently, I think it's 0.2 of a second. And that means in long drawn-out times, you can have lots and lots of render updates and then an occasional physics update. But in a very complicated situation, you can have more physics updates than you have render updates so that you can keep your render engine working properly and your physics engine working with that render engine. So this changes things a little bit. So let's make this, I think it's 5 and 10. I think I worked this out earlier. And now, when we turn, it's just still a bit fast. And then so you can see that we're already turning thrusting. Now that's a little bit out of control, hard to control, so let's add some drag. That may be proper physically, but I want to add some flight control in it. I want to make it easier for me to fly. So I want to increase my drag. If we look down there, we've got mass, we've got drag, and we've got angular drag. So now I want to slow down, and we can see that I've now added drag to it. You can pretend that's air resistance, or maybe my computer in there is giving me reverse thrust to slow me down. And now I can pilot my ship. And this is all in just a few minutes of coding. And I've made some prefabs if we want to see, make it start to look pretty. Under VFX, we can add a star field. Now this is just a particle system. And the same thing with these engines. We can just simply drop those on the player ship. Now we can save and we hit play. Oh, there's my engines. Where's my star field? Anyway, so there's my little flamey engines. And those are particle systems, which is basically a whole bunch of little tiny sprite graphics that are all being blended together. But I've done something strange with my, oh, I didn't drag it in. Pay attention to what I'm doing. Star field, please. There we go. Ah, there's my star field. So, and that star field also is just a simple particle system that runs off the screen and just sends different sized dots, particles down behind the spaceship. So we can see in just a few minutes, we have somewhat of a working stub of what could be a game. I mean, we only have 10 or so minutes for me to put that together, but you can see how quickly you can just throw things together inside the editor. Resources to keep going. So we've gotten this far. Ooh, come back up. The asset store. I'm going to go ahead and show you links to these, but we have a store where you can get assets. If you think I can write code, but where do I get that spaceship? You can get that spaceship from the asset store. That actually is a free distribution. That's something that we have from our Learn section, that spaceship that was done for a tutorial series that I did. There's the community. The community in Unity, the Unity community is very important. Come to the forums. People will help you out. Come ask questions on answers. And again, I'll show you some URLs for this in a second. But don't forget IRC. Does anyone remember IRC? Get on IRC. There's a couple hundred people that are usually there. A lot of them are idle, especially for people like me who work from home. But sometimes you just, there's chat, but sometimes you really want to ask a burning question and you know you're staring at something and it just isn't working and you know you're an idiot. I do that all the time. And get on IRC, post it into haste bin or paste bin. What am I missing here? There's someone there who's going to help. IRC is completely community driven. We have no involvement in it. But I do like to point it out to people because I think it's great. The Learn site, where we have tutorials on how to use Unity. Let me quickly show you these for real. So if we go to Unity, just to the Unity Game Engine site. Come on, you can stretch out all the way. Can't you? No, I don't want to stretch out. Please don't make me. Yes! We can then look at Learn. There's the Learn site. Learn site's very important. You can get to our documentation. Documentation and community also have their own sections. Those are just links to them. But here we have what I do once a week, live training, and the archives for all of the live training that we've done. So you can go back and look at them. And so coming up, I've got coding for the absolute beginner, which I can handle. Then we were talking about our UI, UI panes, some general tips and tricks, and property drawers and customs inspectors. You might want to come by for that if you're interested in modifying the editor and how the editor looks and works and how the inspectors look and feel. Tutorials. We have big projects, simple ones to get started, Rollerball, Space Shooter, you can see that's where the spaceship came from, Survival Shooter, which was the thing that I was using in the background, and Project Stealth, which is intermediate, which has got a lot of interesting concepts and things that you can use on how to use the componentized architecture, how to use hash IDs instead of using string lookups, that sort of thing. You can find that in Stealth. And then all of our modules, most of these are video components. We can describe how to use the component in a video format. And many times we also have associated documentation linked below. So if there's a problem that you want to solve, come to our Learn site, take a look there. Also, documentation, API. Oh, I didn't show that. That's something important. You want to find out about the rigid body? Command, single quote. Brings up a search, shows our documentation. There's the page. So if you're in MonoDevelop, and a lot of people also program this into third-party IDEs that will work with us, you can go straight to the documentation. The community. Come back here, Chrome. If you want to, go to the forum, go to answers. Forum is a traditional forum, but there's a lot of question and answer stuff going on here, so if you have to ask a question that needs a discussion, ask it on the forum. If you really have a specific burning question that you need a specific answer to, try answers. It's very much like a lot of the software-driven question and answer sites where you ask a very specific question, and then underneath are a bunch of answers that can be voted up and voted down on by the community, so you can try to find the answer that you want. And I definitely suggest that you search both of these before you ask, because there's probably an answer already. Asset store. Asset store you can get to outside of the editor. You can also get to it within the editor. And the asset store is where you can download or purchase assets. And these can be 3D models, they can be sounds, they can be textures, they can also be coding frameworks. So if there's something that you either don't know how to do or don't want to do, you can get that here. And often the price, even when it's expensive, it's $100, you compare it to the cost of your day, and it's cheap. And you can find that the solution is sitting there waiting for you on the asset store. So whether it is that you're looking for art, whether you're looking for sound, whether you're looking for a solution to a coding problem, come to the asset store and you may find the solution. And not all of this is expensive. A lot of the stuff here is actually free. What else? We've done IRC. IRC, just to show you where to get to that, because it's a little bit hard to describe. If you go to the community site, we talk about it down here in the lower left. Essentially, it's on freenode.net, and you need to go to hashtag Unity3D, and then you need your IRC client for it. And lastly, as we buzz ahead, let's take a look at Unity 5. Physically based shaders. Not really coding stuff, but certainly it's great eye candy. So we're moving to physical based shaders, which you define what the material is like rather than writing a shader for it. Then you let the universal shader, once you've defined the material of the object, it works with the lighting that you have going on. Reflection probes. So now you can get, we used to have, or we still have, light mapped probes so that you can do dynamic lighting. You put your probes around your set, you bake that into probes. As the character moves between two probes, it interpolates the information between the two probes on the lighting. So you can get dynamic lighting on a character in a baked environment. And now we can do that with reflections as well. Global illumination. WebGL. So we're dropping plugins so that when you go into 5, you can deploy to WebGL. And then whole bunches of new things, new rendering features, lighting systems. We've got an audio mixer that works really nicely. Draw call debugger, so we can add into the debugger. 2D physical effectors, so our 2D physics is being improved. Animation additions, WebGL. Cloud build, which I think is very interesting. We're coming up with a number of services, including built-in cross-platform ads, so that in our API, you want to add advertising to your game, you can just build that in. You can say, if the ad is downloaded, please run it now, just in one of your behavior scripts. And cloud build is where if you have a repository, Git, I think Bitbucket, can't remember all of them because it's in beta, you can then go to a dashboard and say, I would like my iOS build, I want a Linux build, I want an Android build, and I think we can do consoles as well in that. And hit a button, walk away. It goes and finds your repository, brings it up into the cloud, builds you your executables, sends you an email. You can download it. If you've got distributed studio, you can authorize people to download it at the different places. They can bring it down onto their devices to test. My guess is that the monetization will be you'll get a limited amount for free. And then if you want to get into doing daily builds to multiple platforms, there will probably be a subscription scheme of some sort that's in beta. So definitely worth looking at. So 5 minutes. Any questions? Yes. Yes, to be honest, it's not something I do a lot of, and I know it's gotten better. There are some things that can be problems where if you're both working in the same scene at the same time. In one sense, this is something you might want to ping me about because I know that there are some actual specific answers that are out there. One example is work in prefabs. I had to skip over the prefab section because I knew I was running out of time. But briefly, the idea of prefabs is that you can create any game object that's as complex as you want to in the game, pull it into your project view, and it makes an asset out of it. And then you can reuse that asset. So all of the monsters, you make one monster that we had in the game with all of its behaviors, make a prefab, spawn as many as you want, hundreds of them. So you can set your scenes up so that people are working on prefabs, and they're not touching the scene. And then they make all the changes to the prefab, and the scene basically goes, well, I have a prefab here. And the changes have been made to the prefab so that you're not dirtying the scene. There is something about text-based saving of the scenes that allows merging, but I can't remember what state that's in or where it is between 4 and 5. So there are solutions to that coming. Ping me at the Ant Ranch or at adamb@unity3d.com, and I will try to get you a better answer. The other thing is, before I ask for another question, we got 3 minutes. If you want to get a hold of me and you want to ask a question, one of the best ways to do it also is to make a forum post or an answers post, and then PM me or ping me at any of these numbers with the URL, and then I'll answer it because it's very much easier for me if I have to bring in a dev or someone from support to have the forum post than trying to pass around a tweet or an email. Any more questions? None? One way in the back. It's taken care of for the build level. What I didn't show here is that if we looked at our script, that won't work on iOS because I haven't asked for any touch information. You can also do platform defines. So I can say if iOS, Android, Surface, whatever is touch, if my input is a touch, then, or else if in the editor and on a keyboard and mouse device, use the input get axis. So, and I can also do my own defines, not just platform defines. You can also say, if this is a demo, play the first level and bug the person to buy up the upgrade, or else take them to level 2 when they're finished. Because the whole idea of the way the editor works is you want to have one code base, one project, or one code base and one project, and be able to put that out on all of your platforms in all of your different versions. If that makes sense. You have a question. What is the pricing like? That's really a very good question. Currently, because we haven't moved into 5, and I don't know what's going to happen in 5, there is a free version. And most features are available in the free version. And that includes build targets and iOS. The only thing that is not included in that is consoles. But that's because you also need a license from the console people as well. Now many of the packages for the consoles are included with the console SDK. So most of the major consoles we have a deal with that if you get the console SDK, you get a version of Unity Pro with it. Then there is a Pro package, and the Pro package starts at $1,500 per license, but there is no royalty. So this is unlike some other software companies that the price of entry is cheap, but then you owe 5% of your game to that company, and you need to account for it. Whereas with Unity right now, it's free. You get, I would argue, 95% of the usability for free, and then some of the very high-end features are reserved for Pro, and that's $1,500 for the Sleet license. And currently, if you buy the license, you get 5. We're essentially selling licenses to 5, and you get 4 for free. Anything else? All right. And if you need me, grab me. I'll be in the lobby. I'll answer any questions I can. Thanks.